In this lesson, we're going to go ahead and work with our transformations and parent graphs on how to take an equation with multiple transformations and be able to draw its graph, and also go the other way. But before we do that, let's just do a review of our transformations. First off, I'm going to go ahead and write the general form of the function. In this case, f of x is equal to a times bx minus h plus k. So in this case, just like we learned back in lesson 1.2, the a, the b, the h, and the k are all going to have different effects on the graph depending on the transformation that we're given. Let's start with the k value. The k value, if it's positive, is going to shift the graph up. If it's a negative, though, this is going to shift the graph down k units. Similarly, the h value is going to shift it left or right. If it's positive, it will shift it left h units, and if it's a subtraction sign, it's going to shift it right k units. These right here make up our translations. Next, let's talk about our a. If the a is negative, this is going to be a reflection or a flip over the x-axis. If our a value is greater than 1, this is going to result in a vertical stretch, making the graph skinnier. If the a is between 0 and 1, this right here is going to be a vertical shrink or compression, making the graph wider. And finally, let's talk about b. b, if we have a negative on the x value, this will be a reflection or flip over the y-axis. And if b is greater than 1, this will result in a horizontal compression, making the graph skinnier or thinner. But if it's between 0 and 1, this will result in a horizontal stretch, which will make the graph wider. This right here is something that we need to know by heart so we're able to go between the equation and graph. In lesson 1.2 at the very end, you talked about the correct order for how to do multiple transformations at once. Remember, this is where we talked about our acronym, the HACK, or in this case, H-A-K. The H here stands for our horizontal translation. So whatever the H value is in our equation, that's what we're going to do first. The next thing we're going to consider is the A value. This will include any flips or reflections, or stretches or compressions. The very last thing we want to do is worry about the K value, which is our vertical translations. So we're always going to follow the order of the equation, the H, the A, and then the K value. You can think of the B value as the same thing as the A at the same time. So just always make sure that's in the middle. So let's consider our new function down below. Again, noticing that it is a function because it passes our vertical line test. Like before, I'm going to go ahead and write down our original points so we can use these to help us. So we have the points -2, -2, -4, 0, 0, 0, and 2, 4, and 4, 0. In our first graph here, we notice that I've underlined in the blue, the -1 is on the inside, and the -3 is on the outside. That means here that that -1 is, since it's on the inside, will be a horizontal shift right 1, and then the -3 on the outside is going to be a vertical shift down of 3. Following our order, we need to make sure to do the horizontal shift first, and then the vertical shift. So this will result in adding 1 to all our x values, but then subtracting 3 from all our y values. By doing this to our points, then we can go ahead and get our new coordinates of our points, which will result in the transformed graph. Notice if we compare the original to this guy, we see that everything has been shifted right 1 and down 3. In our next example here, we have a 1/2 on the inside. This right here means that it will be a horizontal stretch to our graph. This means that we need to divide all our x values by the reciprocal here, or in this case, divide by 1/2, which means multiplying by 2. And so our x values here are all going to be doubled. So that -4 becomes -8, -2 becomes -4, and so on. Notice nothing's happening to our outputs here because there is nothing, no transformations in the equation. If we compare the original graph to our transformed graph, we can see that it has been horizontally stretched, i.e. being pulled away from our y-axis, or from our x-axis. I'm going to go ahead and draw in our original graph here again and give those points. In this equation, we have 3 different values for the a, the h, and the k. We have an h of -1, an a value of -1/2, and then a +3 for our k value. Following our orders, we need to do our horizontal translation first of adding 1 to all the x terms. And then we're going to do our, in this case, our dilation, our stretch here, actually a compression, my bad, of -1/2, which is also our flip, by multiplying all our outputs by a -1/2. And then finally, we're going to worry about our k value by adding 3 and shifting everything up 3. So you can see that as I did our different colors here, these are affecting all our different transformations. So if I go ahead and compare and draw that graph in and highlight it a little bit more, that should be straight lines, we can see that the graph has been shifted right 1, flipped over the x-axis, compressed by 1/2, and also shifted up 3. Our next graph here is we have a vertical stretch by 2 and a vertical shift up 1. This means that we need to multiply all our outputs by 2 first and then add 1. Notice our inputs are not going to be changing here at all because there is nothing else affecting the inputs. It was all affecting the outputs. Our last example here, we'll be shifting the graph right 2 because of the -2 on the inside, and then we have an a value of a -2. So this will be shifting the entire graph 2 by adding 2 to all the x values, but then we can handle that flip and that stretch by multiplying all our outputs, or our f of x's, by a -2. If we compare our black graph to this pink graph, we can see that it has been shifted right 2 and also flipped upside down and stretched. Remember to always follow our hack, the HAK, when applying multiple transformations. The next thing we want to be able to do here is, based on the equation, actually draw our graph. This is where our knowledge of parent functions are going to have to come into play. First thing we have to note here is, based on the equation, is what type of graph are we working with? Well, if we notice the square here, this means that this is going to be a quadratic graph, making this a parabola shape, or a U shape. Also, if we look at the equation, we can get our transformations. We know it's going to shift right 2 because of the -2 on the inside. We're also going to have a flip over the x-axis because of the -a value. And then also, since the a value is 2, this is going to be a stretch of 2 of our original graph. So I always like to start by drawing the original parabola in. And so if we do that here, we're going to go ahead and get our quadratic. So our original quadratic always starts at 0, 0, and then goes up 1 in both directions, and then goes over 2, up 4 in both directions. So instead of using the table of values, I want us to use these transformations by just drawing them as we go through them, using our hack. So starting with 0, 0, we can go ahead and shift the graph right 2. And then we know that's going to be opening downward since it's flipping over the x-axis. And then to do the vertical stretch by 2, instead of going over 1, up 1, in this case, we want to go over 1 in both directions, but down 2. This will give us that stretch of 2, giving us our graph. We can use our table of values here if we would like to do that, if we want to write down our coordinates, but we can also just use our knowledge of transformations and use our graph to help us if we'd like to do that process as well. In the second example here, we had a mistake. That -2 should be on the outside of the absolute value bars. But this is an absolute value graph, which means that our graph is going to be that V shape. Based on our transformations here, we can look and we will see that this is going to be shifting right 1 because of the -1 on the inside, down 2 because of the -2 on the outside, and then also we're going to be a vertical compression by 1/2, which means this graph is going to get wider or grow away from the y-axis. So to do that, we're going to start by using our hack. So we're going to shift right 1 first for the h value. We know we're going to have to do a vertical compression. So in this case, instead by 1/2. So in this case, instead of going over 1 up 1, since that is going to affect our x value, we're going to go over 2 this time instead of 1, and then go up 1 from there, making that graph wider. And then finally, all we need to do is shift down that point to down 2 to be at 1, -2. So from here then, we can draw our points outward by going over 2 in both directions and up 1. And that right there will give us our transformed graph. In the last example here, we see that we're working with the square root graph. The square root graph is maybe a little bit different than what you remember, but remember it starts at 0, 0, and then we're going to go over 1, up 1, and then over 4, up 2. Kind of like that sideways parabola, but missing that bottom half. So this right here is our parent shape. If you look at our equation, we will see that our transformations are being flipped over the y-axis, since the negative is on the inside of the radical. And then also we're being shifted down 1 since it's a -1 outside the radical. So this means first, since there is no changes to the h value, you don't need to worry about that. But the flip over the y-axis means that instead of having our graph go out to the right, we're going to be going out to the left. And then from there, we need to worry about our k and shift down 1. So if we go ahead and open up to the left and shift down 1, and then draw on our points going over 1, over 4, we're going to get this transformed teal graph. The last thing we want to be able to do here is go from the graph to the equation. So on the first one here, we notice that it is a parabola. So that means this is going to be a quadratic. So if I draw in the original quadratic shape, I'll do that here in a sec. After, I'm going to go ahead and write out our equation here. That way we know we have spaces for the a, the h, and the k that we can fill in. So the normal quadratic looks like this. And so if we go from 0, 0, we know that it's been shifted right 2, up 1. And so that means that we can write in our equation a -2 on the inside and a +1 on the outside for that k value. Next thing we need to look for is for the a. We notice that it's still opening up, so it hasn't been flipped at all. But if we look at the scale, it's going over 1, up 3. This means that it has been vertically stretched by 3. And so this right here would be our quadratic equation. Our next graph, well, is that V shape that we know as absolute value. So I'm going to go ahead and rewrite my equation, leaving blanks for the A, the H, and the K, using the absolute value bars this time. And I'm going to draw in the normal absolute value graph. Again, so if we look at the original parent graph and compare it to our blue, we notice that it has not been shifted, in this case, to the left or to the right or up and down. So our H and K values are just going to stay 0, or we can leave them blank. But if we look, it is opening down now. And so that means we're going to have a negative A value. Furthermore, instead of going over 1, up 1 like the normal absolute value, this one is going over 2, down 1, meaning that it has been vertically compressed, making it wider. So that by a factor of 1/2, since it's going over 2, down 1. So we get our final equation here to be y equal to, or f of x, equal to -1/2 times the absolute value of x. And finally, in our last example, notice that it is the S curve. So this is going to be our cubic graph. Remember, our normal cubic graph is that S curve, which is increasing. And it goes over 1, up 1, and then over to the left, down 1. So I'm going to go ahead and write in our blanks for the A, the H, and the K, for this case using our cubic graph. Notice it has been shifted right to from that 0, 0. And so since we're moving right to, then that means our H value here is going to be a -2. Since it has not been moved up or down at all, that means our K value is going to stay 0, or we can leave it blank. And then finally, though, for our A value, we notice that it has been flipped. And so since it is decreasing in this case. So since it has been flipped, in this case over the x-axis, that means our A value is going to be a -1, or you can write that as just a negative on the outside. So our final equation here will be y equals -x minus 2 all cubed.